Hello everyone. Good afternoon. Good afternoon, students. Welcome. How are you, students? Welcome everybody. Welcome. Welcome everyone. So, students, in today's class, first of all, please let me know quickly in the chat box. My voice is clear or not, and the screen is visible or not? Please let me know quickly, everyone. Screen is clear. Everything is clear, right? Yes, very good, Pavre. Very good. So Parve, could you please let me know in the chat box that my audio is clear or not and the screen is visible or not, so that we can start with today's lecture. Clear? Okay. So let's start then. So student, in the last class, we were having the discussion about the limits, right? How to find the limit, and we did solve some of the example and to show you that how to eliminate the indeterminate form, right? We have seen so many ways to eliminate the indeterminate form, right? We can use the factorization method, rationalization method, right? And then double rationalization, right? And then create infinity in denominator, right? So these all things we have seen in the last class, right? So let's continue with that. So in today's class, we are going to continue with this only. So first of all, I gave you some homework question in the last class, right? So we'll have the discussion on the homework question, and then we will continue with the important results. Okay. And then we will look on to the more questions on the important results. Okay. So shall we start? Okay. So first question is this. Everyone, tell me how many of you have solved this question? Quickly let me know in the chat box. How many of you have solved this question? It is very important question actually. Okay. So everybody please pay attention here. So let's see what is written. It's written limit x tends to 1. K is varying from 1 to 100. X raised to the power k minus 100 upon x minus 1, right? So first of all, if x is 1, right? So it is summation over 100 times of 1. So it will be 0 by 0 form, right? Numerator will be 0 and denominator will be 0, right? At x is equal to 1. So it means this given example is of 0 by 0 form, right? So we have to eliminate. So let's solve it. So first of all, let's see. This is written limit x tends to 1. And what is this written? It is written x raised to the power 1 plus x raised to the power 2 plus x raised to the power 3 plus x raised to the power 100, like this, minus 100 divided by x minus 1. Clear? Okay. So again, what you can do is, student, you can write this as x minus 1. So what I'm doing, I'm breaking this 100 in 100 parts. So 1, 1, 1, 1, 1, right? So this can be written as x minus 1 plus x square minus 1 plus x cube minus 1 plus and so on so forth up to x raised to the power 100 minus 1 divided by x minus 1. Correct? Correct, right? No problem so far. Okay. So now this can be written as limit x tends to 1. What is this? It is now, see, can we separate the limit? We can separate the limit, right? So it can be written as x minus 1 upon x minus 1 plus limit x tends to 1 x square minus 1. 1 को लिख सकते हो 1 square, right? Upon x minus 1 plus limit x tends to 1. This can be written as x cube minus 1 cube divided by x minus 1 up to limit x tends to 1, x raised to the power 100 minus 1 raised to the power 100 divided by x minus 1. So I have just separated the limit, right? So using the sum formula. So in the last class, we have seen the sum formula, right? So I have used that formula. Okay. So now, student, as you can see, each of these limits are in the 0 by 0 form, right? Each of these limits are in the 0 by 0 form. Yes or no? Tell me. right? Okay. So if you remember from the last class, I told you one formula that limit x tending to a, x raised to the power n minus a raised to the power n upon x minus a is nothing but n times a raised to the power n minus 1. You remember from the last class, right? So using this formula on the each of this limit, see, as you can see, it is x raised to the power n minus a raised to the power n upon x minus a, where x is tending to a, right? So in each of this limit, we can plug this formula, right? So this is nothing but for the first one, it is 1 plus, what is this? What is n? N is 2. So 2 into a is 1 raised to the power 2 minus 1 plus, for the third is x cube minus 1 cube upon x minus 1. What is n? N is 3. 3 into a is 1 raised to the power 3 minus 1, right? Plus similarly 4 into 1 into 4 minus 1 up to 100. Last one in the last limit, the n is 100. So 100 into 1 raised to the power 100 minus 1. So what is this? It is nothing but 1 plus 2 plus 3 plus 4 se leke 100, right? So it is what? Sum of first n natural terms, right? So what is this? N into n plus 1 by 2, right? So n is 100, n plus 1 by 2. It is nothing but 5050 is the answer. Clear? Is this clear? Tell me quickly in the chat box, how many of you understood this? Clear, right? So the question was given, we have break that complicated long expression into the small limit, right? And then find the limit of individual expression and then add it, right? So that's why I've told you in the last class also, the fundamental of the fundamental theorems in the limits are really important, because we will be using them in all the questions. Most of the questions we will be using them. Okay, I hope this is clear now. If you have any doubt, students, please let me know in the chat box. Clear? Okay, if it is clear, then let's proceed to the next question. This question, can anybody tell me the answer in the chat box? What is the answer of this question? Again, this is the question I gave you in the homework, right? What is the answer? So it is saying, first of all, what is this limit? Is as x tending to infinity, as x tending to infinity. So this is infinity into 1 upon infinity is 0. So sine 0. So it is a form of infinity into 0, right? Again, one of the out of the 7, one of the indeterminate form, right? 0 into infinity. So how we are going to solve it? Student, do you remember this thing? Limit x tending to 0, sin x upon x is equal to 1. Limit, right? Means, is this clear? Is this clear? Okay. So as you can see, here you can write this as limit x tending to infinity, sin 1 upon x upon 1 upon x, right? Yes or no? Now, let 1 upon x is equal to y. So, थोड़ी देर के लिए let assume 1 upon x is equal to y, right? So as x tending to infinity, y will tend towards 0. Yes or no? As x tends towards infinity, y will tend to 0. So this limit can be written as limit y tending to 0, sine of 1 upon x is y, sine y upon y, which is what? Limit elephant tending to 0, sine elephant upon elephant is 1. Clear? Is this clear? Is this clear? Tell me quickly in the chat box, how many of you understood this? How many of you have understood this? Clear, right? It's a very small question, right? Very easy question, but you have to remember that, see, directly x is tending towards infinity. So first we have converted in the form of 0 by 0, right? Now this is in the form of 0 by 0, right? So now we can proceed with it, right? Clear? I hope this is clear. If you have any doubt, ask me, please. Is there any doubt, students? Okay. So now this question, third question. It is also, again, please mark this is an important question, everyone. Important question. Okay. Question is saying that limit x tending to infinity, x square plus 1 upon x plus 1 minus ax minus b is equal to 0. Means the limit of this expression is 0. Then find, so question kya hai? Find a and b. That is the question. Okay. Find a and b. If the limit of this expression is given, then find a and b. That is the question. Clear? So did anybody solve this question? Anyone? Nobody? Okay. Please, everyone, please pay attention. This, see, in the exam now, you will see this type of question so much time, so many times. Frequently, you will be seeing this type of question. The limit of some expression will be given, then find the unknown in the expressions. Okay. So these type of questions occurs very frequently in the limits. Okay. So please pay attention here. How we are going to solve it. Okay. सबसे पहले, what is this written? Limit x tending to infinity, x square plus 1. Take the LCM. Okay, take the LCM. LCM is x plus 1, right? LCM is x plus 1. Take the LCM. So minus ax into x plus 1 minus b into x plus 1. So this limit is 0, right? So now this can be written as limit x tending to 0, x square plus 1 minus ax square minus ax minus bx minus b divided by x plus 1 is equal to 0. Clear? Now, what is this can be written? This can be written as limit x tending to 0. Coefficient of x square is 1 minus a. Right? Plus, what is the coefficient of x? Minus a minus b times x plus 1 minus b is the constant divided by x plus 1. Limit tending towards infinity, right? Limit tending towards infinity is 0. Is this clear so far? Clear, right? So students, please pay attention now. See, one of the concepts that now I'm going to tell you is, see, as you can see, it is nothing but infinity upon infinity form, right? Infinity upon infinity. So what we do? We try to create infinity in the denominator, right? We try to create infinity in denominator. Is this clear? But see, student, one problem that you will face. Now let's please focus here. See, if I tell you limit x tending to infinity, x square plus 1 upon x square plus 2. What you will do? You will divide the numerator and denominator with x square, right? So you will say, sir, it can be written as limit x tending to infinity 1 plus 1 upon x square upon 1 plus 2 upon x square. And now substitute the x is equal to infinity. So this can be written as 1 plus 0 upon 1 plus 0, right? As you can see, why we are able to do this? Because the highest power of the numerator and the denominator when x is tending toward infinity is equal. Yes or no? Yes or no? For example, what if this happens? Please pay attention here. What if I ask you limit x tending to infinity, x square plus 1 upon x plus 1, right? So you will say that, what you will say? Tell me. You will say, sir, x square plus 1 upon x plus 1, numerator and denominator is not having same power, right? So divide this with x, right? Divide numerator and denominator with x. So it can be written as x plus 1 upon x upon 1 plus 1 upon x. And now when you put x is equal to infinity, it will tend towards infinity, right? So it means if whenever you have infinity upon infinity form and the limit is finite, it means the highest power of the numerator and the denominator is equal. Are you getting my point? What I'm saying is, since limit of infinity upon infinity form is finite, it means highest power, highest exponent of numerator is equal to highest exponent of denominator. Is this clear? This is the concept, okay? This is the very concept. Is this clear? Is this clear or not? Tell me. Right? So it means power of the numerator is 2 and power of the denominator is 1. So it means for this limit to be exist, it implies for above limit to be exist, the coefficient of x square from the numerator should be equal to 0. Yes or no? Exist coefficient of x square should be 0. Is this clear? Because the highest power in the denominator is 1. Right? So it means the highest power in the numerator should be 1 for this limit to be exist. Am I clear? So what does this mean? It implies, what is the coefficient of x? What is the coefficient of x square? 1 minus a. So it implies 1 minus a is equal to 0. So it means value of a should be equal to 1. So a is the value of a we got, right? Value of a should be equal to 1. Is this clear? Okay. If it is clear, substitute the a in the limit. What we will get? We will get limit x tending to infinity. Since now we have substituted a, so x square ka coefficient is 0. So now we will get minus 1 minus b times x, minus 1 minus b times x plus 1 minus b upon x plus 1. 1 minus b upon x plus 1. This limit is 0. So now again this is now is a infinity upon infinity form, but coefficient of highest exponent in the numerator and in the denominator is equal. So what we will do? Divide the numerator and denominator with x, right? So this will become 1 minus b plus minus 1 minus b plus 1 minus b upon x divided by 1 plus 1 upon x. This limit is 0. So find this limit. How you will find the limit? We have created the infinity in the denominator. So now substitute the x equal to infinity. What you will get? Minus 1 minus b plus 1 minus b upon infinity is 0 divided by 1 plus 1 upon infinity is 0. This is equal to 0. Clear? So it implies minus 1 minus b is equal to 0. So it implies b kitna aa gaya? Minus 1. Clear everyone? Is this clear? Please let me know quickly in the chat box. Is this clear or not? Is this clear? So it means value of b is minus 1 and value of a is 1. Clear? Please let me know quickly in the chat box. Is this clear? So whenever you have this type of question, so you have to use a little common sense, right? Okay. So since infinity upon infinity form is there and limit, it's saying limit is finite, which is 0, right? So it means highest degree in the numerator and the denominator should be same, right? So that's why the coefficient of x square should be 0, right? And then find the limit by creating the infinity in the numerator. Is this clear, students? Okay. If it is clear, shall we proceed further then? Okay, very good, very good, very good. Okay. So let's proceed further. Okay. So now let's solve this question. Okay. Now solve this question. This question is saying that limit x tending to pi by 2 tan square x into square root of 2 sin square x plus 3 sin x plus 4 minus square root of sin square x plus 6 sin x plus 2. Okay. First of all, tell me as x tending to pi by 2, tan x will tend toward infinity, right? Now, what is this? Put x is equal to pi by 2. So you will get 2 plus 3 plus 4. So root 9 minus under root of 1 plus 6 plus 2. So root 9 minus root 9, 0. So it means this is a form of infinity into 0. Right? This is a form of infinity into 0. Clear? So student, solve this question. I'm giving you 1 minute. Okay. I'm giving you 1 minute. Now I have told you this is the form of 0 into infinity. I have given you 1 minute. Solve this question and let me know the answer quickly in the chat box. Everyone, you have 1 minute to solve this question. Your time start now. Solve it and let me know the answer. Let me know the answer quickly. It is a 0 into infinity form, right? Tell me the answer, everyone. Yes, JNV Balari. Did you get the answer? Quickly. First of all, what you can do? Square root you are seeing, right? So first of all, you have to do the rationalization, right? That is the obvious step. That is the first step we can think of. So do the rationalization and then proceed from there. Okay. Do it, everyone. Let me know the answer. Everyone, let me know the answer. Anybody got the answer? Okay. So let's see here. Please, everyone, pay attention. Everyone, pay attention here. So first of all, we have to do the rationalization, right? We have to do the rationalization. So this can be written as limit x tending towards pi by 2 tan square x into square root of 2 sin square x plus 3 sin x plus 4 minus square root of sin square x plus 6 sin x plus 2, right? Into multiply and divide by square root of 2 sin square x. 1 second. So what you will do? Rationalize, right? Rationalize. Let me use the different pen. Yeah. Into square root of 2 sin square x plus 3 sin x plus 4 plus square root of sin square x plus 6 sin x plus 2 divided by under root of 2 sin square x plus 3 sin x plus 4 minus plus under root of sin square x plus 6 sin x plus 2, right? So we have done the rationalization, right? So further than that, what we will do? Now, this can be written as limit x tending towards pi by 2 tan square x. Now, what is this written? A minus b into a plus b. A minus b into a plus b, which is a square minus b square. So this is nothing but 2 sin square x plus 3 sin x plus 4 minus sin square x minus 6 sin x minus 2 divided by under root of 2 sin square x plus 3 sin x plus 4 plus under root of sin square x plus 6 sin x plus 2. Clear? So what is written? It is written limit x tending towards pi by 2 tan square x sin 2 sin square x minus sin square x sin square x 3 sin x minus 6 sin x minus 3 sin x 4 minus 2 plus 2 divided by, see student, since what is this limit? this is put x is equal to pi by 2. So infinity into again 0. So numerator is again 0 into infinity, but in denominator we don't have any indeterminate form, right? In denominator we don't have any indeterminate form. Clear? So it means I can separate my numerator and denominator. Yes or no? It means I can separate my numerator and denominator. Clear? Is this clear? So this can be written as limit x tending towards pi by 2 under root of 2 sine square x plus 3 sine x plus 4 plus under root of sine square x plus 6 sine x plus 2. Is this clear? Is this clear? Tell me quickly in the chat box. Is this clear or not? Is there any doubt? Janvi, Balari, Karthik, is there any doubt? Quickly let me know in the chat box. Okay. If it is clear, then let's proceed further. So in the denominator, we can put x is equal to pi by 2, right? So substitute karo x ko pi by 2. So what you will get? You will get, सबसे पहले, this can be written as limit x tending towards pi by 2 tan square x into what is this sine square x minus 3 sine x plus 2. So factorize this. On factorization of this, it can be written as sine x minus 1 sine x minus 2 divided by, substitute x is equal to pi by 2. So what you will get? Square root of 2 plus 3 plus 4, 9 plus root 9. So it is nothing but 3 plus 3, 6. Is this clear? Is this clear or not so far? Tell me quickly in the chat box whether it is clear or not. I have just rationalizing it, and since we don't have any indeterminate form in the denominator, so what I'm doing is I'm using the quotient rule. Okay, separating the numerator and denominator, right? And we have directly find the limit of denominator by putting x is equal to pi by 2. That's it. So this can be written as 1 by 6 limit x tending to pi by 2 tan square x into sin x minus 1 into sin x minus 2. So tan square x can be written as sin square x upon cos square x sin x minus 1 sin x minus 2. Clear? So this can be written as 1 upon 6 limit x tending to pi by 2 sin square x sin x minus 1 sin x minus 2, and cos square x can be written as 1 minus sin square x, and that 1 minus sin square x can be written as 1 minus sin x into 1 plus sin x. Is this clear? Is this clear? Why? Because cos square x is equal to 1 minus sin square x, and it can be further factorized. So see, it means it can be written as 1 by 6 limit x tending to pi by 2 sin square x. This can be written as 1 minus sin x into 2 minus sin x, right? Take the minus common from this bracket and multiply that minus in the different bracket, divided by 1 minus sin x into 1 plus sin x, right? So 1 minus sin x and 1 minus sin x can be cancelled out. And now, as you can see, we no longer have any indeterminate form, right? So now we are free from the indeterminate form. So we can now directly substitute x is equal to pi by 2. So it can be written as 1 by 6 into sin pi by 2 is 1 into 2 minus 1 divided by 1 plus 1. Clear? So this is nothing but 1 by 12. So 1 by 12 is the answer. Clear, everyone? Is this clear? Quickly let me know in the chat box. Is this clear or not? Janvi Balari, is this clear? Clear, right? So, just we have done the factorization, and after the factorization, we have remove the 1 minus sin x. Okay, after removing the 1 minus sin x, cancelling from the numerator and denominator, we can see we have no longer indeterminate form. So then we can directly substitute x is equal to pi by 2. Clear? Okay, very good, Genuine Balari. Very good. If it is clear, then let's proceed further. Okay, let's proceed further now. Okay. So students, in the last class, we were having the discussion on the important results. Okay. So far we have done the some homework question and some important question. Okay, of the limits. So now we will again come back to the important results. Clear? So in the last class, we have seen these three results, right? Limit x tending to a, x raised to the power n minus a raised to the power n divided by x minus a is equal to n times a raised to the power n minus 1. Clear? And limit x tending to 0 sin x upon x is 1. And this will be same as limit x tending to 0 x upon sin x. Why? Because as you can see, limit x tending towards 0 x upon sin x जो है इसको क्या लिख सकते हैं? It can be written as limit x tending to 0 1 divided by sin x upon x, right? So this can be written as 1 divided by limit x tending to 0 sin x upon x, which is nothing but 1 by 1. So that's why the limit x tending to 0 x upon sin x is also 1 and limit x tending to 0 sin x upon x is also 1. Clear? So same with limit x tending to 0 tan x upon x is 1 and same as limit x tending to 0 x upon tan x. Is this clear? So these three things we have discussed in the last class, right? Clear? So if it is clear, then let's move to the more important result. So the fourth one, student, the fourth one is limit x tending to 0 1 minus cos x upon x square is 1 upon 2. So the result of this can be verified using the L'Hopital rule also. Okay, you can use the L'Hopital rule here. See, if you want the proof of it, you can see here. Using the L'Hopital rule, this can be written as limit x tending to 0. Different, since it is a 0 by 0 form, right? As x tending towards 0, this will be 0 by 0. So 0 by 0 form hai. So we can use the L'Hopital rule. Yes or no? So differentiate the numerator. So 1 minus cos x ka differentiation is sin x. X square ka differentiation is 2x. So this is written as limit 1 by 2 limit x tending to 0 sin x upon x. And this result we know it is nothing but 1 by 2 into 1. So half aa gaya na automatically. As you see, right? So it means limit x tending to 0 1 minus cos x upon x square kitna hota hai? 1 by 2. Remember. Okay. And similarly, limit x tending to 0 e raised to the power x minus 1 upon x is nothing but 1. Again, you can use the L'Hopital rule. This is nothing but 0 by 0 form. Yes or no? This is nothing but 0 by 0 form. Okay. If it is 0 by 0 form, so we can use the L'Hopital rule. So using the L'Hopital rule, we will get differentiation of e raised to the power x minus 1 is e raised to the power x. Differentiation of x is 1. So now we no longer have indeterminate form. Substitute x is equal to 0. We will get e raised to the power 0, which is 1. So it means e raised to the power elephant minus 1 upon elephant, where elephant is tending towards 0 is 1. Clear? So what I mean to say, it's just not for x, any expression. Okay, what I mean to say is limit f of x tending to 0 e raised to the power f of x minus 1 upon f of x. It will be also 1. Clear? And similarly, limit f of x tending towards 0 1 minus cos of f of x divided by f of x. This will be half. Okay. So don't be confused that it is only for the x. No, x is just an expression. Okay. Inside of x, if instead of x, if there is any other function which is tending towards 0, then also the same limit will give the same answer. Clear? The same limit is applicable. Clear? So if it is clear, so now student, tell me the answer of the sixth one. I want the answer of sixth one. Limit x tending towards 0, a raised to the power x minus 1 upon x. What is the form? First of all, tell me x tending towards 0, a raised to the power 0 is 1. So 1 minus 0, 1 minus 1 upon 0. So it is again 0 by 0 form, right? It is again 0 by 0 form. So if it is a 0 by 0 form, so we can directly use the L'Hopital, right? We can directly use the L'Hopital. So using the L'Hopital, what we will get? Differentiation of numerator. Differentiation of a raised to the power x is a raised to the power x ln a. Differentiation of 1 is 0 divided by differentiation of x is 1. So now we no longer have indeterminate form. Yes or no? Now we no longer have indeterminate form. So substitute x is equal to 0. You will get a raised to the power 0 ln a, which is ln a. Which is ln a. Clear? Is this clear? Ln a. So it means limit x tending towards 0, a raised to the power x minus 1 upon x is ln a. Clear, everyone? Please let me know the answer in the chat box. Is this clear or not? Everyone, is this clear? Is this clear? Janvi Balari, Janvi Chitra Durga. Please let me know in the comment box. Is this clear or do you have any doubt? Okay. Okay, very good, very good. If it is clear, then let's proceed further. So these are the 6 important results we will be using, okay? And there are more than that also, but for now, we will be concentrating on these 6 important results, okay? And now students, as see, there is one more thing about the result is, this result can be derived using the series expansion also, as it is not in our syllabus, okay? But I'm just telling you because sometimes in the limit, we can directly solve the question by using the series expansion, okay? So it just come in handy if you remember this series, okay? Or directly you can use the limits, you can use the way, you can use the limit method to find the limit. But sometimes finding the limit using the series expansion becomes little easy. That's what I'm saying, okay? So these are some limits, okay? These are some limits. First is a raised to the power x is nothing but 1 plus x ln a upon 1 factorial plus x square ln square a upon 2 factorial plus x cube ln cube a upon 3 factorial and so on is up to infinity. Clear? These all series are going up to infinity. Okay, this is for a greater than 0. E raised to the power x का expansion होता है 1 plus x upon 1 factorial plus x square upon 2 factorial plus x cube upon 3 factorial and so on up to infinity. ln 1 plus x where x is between minus 1 and 1 का expansion होता है x minus x square by 2 plus x cube by 3 minus x raised to the power 4 by 4. Okay, sin x का expansion is x minus x cube upon 3 factorial plus x raised to the power 5 upon 5 factorial minus x raised to the power 7 upon 7 factorial and so on. Cos x is 1 minus x square by 2 factorial plus x raised to the power 4 upon 4 factorial minus x raised to the power 6 upon 6 factorial. Clear? Okay. Similarly, tan x का expansion होता है x plus x cube upon 3 plus 2x raised to the power 5 upon 15. Okay. And 1 plus x raised to the power n, where n is the natural number, sorry, n is a rational number, is 1 plus nx plus n into n minus 1 upon 2 factorial into x square and so on. Okay, up to infinity. So these are the series that you have to remember. Okay, I'll tell you the importance of it. For example, students, for example, everybody knows the limit. See, now let's find the limit of x tending towards 0 sin x upon x, right? So if I don't want to use the L'Hopital rule, so one thing I can do is I know the expansion of sin x, right? Sin x का expansion क्या होता है? X minus x cube upon c, x cube upon 3 factorial plus x raised to the power 5 upon 5 factorial minus x raised to the power 7 upon 7 factorial and so on up to x. So this is nothing but limit x tending to 0, 1 minus x square by 3 factorial plus x raised to the power 4 upon 5 factorial and so on, right? As you can see, this is no longer in indeterminate form. So now substitute x is equal to 0, you will get 1. Clear? So using the limit also, we can find the value of the series, value of the limit. Using the series expansion, we can find the value of limit. Is this clear? So that's why if you remember this series, then it is very beneficial for you guys only. Okay? Because in exam, sometimes directly by expanding the series, we can get the answer. Okay? So that's why you should know as much things as possible, so that if the questions come, so you guys are ready to solve it using so many methods. Okay. So that's why it's very important. You should know so many, like you should at least know 2-3 ways to solve a question. Okay. If you have that habit, so in exam, you will definitely will remember that which of the ways is a shortcut to solve the question in very less time. Is this clear? So that's why I'm telling you this expansion. Okay, although it is not necessarily, but still I'm telling you because many questions can be able to solve using the expansions. Okay. Okay. So I hope you will remember this. And these are very easy expansion. Okay. See, remember the x e raised to the power x expansion. Remember the e raised to the power x expansion. A raised to the power x can be written as e raised to the power x ln a. Right? E raised to the power x ln a. So now, what is this? A raised to the power x is nothing but e raised to the power x ln a. So substitute x as x ln a in the e raised to the power x expansion. You will get the expansion of a raised to the power x. Clear? So like that also you can remember. Is this clear? I hope this is clear now. Okay. So bottom line is, please remember this expansion, because in exam directly sometimes we can directly get the result by just expanding the series of the sine or cos. Okay. If this is clear, then let's proceed further. So now let's solve some questions. Okay. So we have seen some important results, right? So now we are ready to solve some questions on the basis of it. Okay. So first question is, limit x tending to 0 under root of 1 plus tan x minus under root of 1 plus sin x upon x cube. Okay. So everyone, सबसे पहले, as you can see, this is square root, right? So one thing that is very obvious, the first step which is very, very obvious is the rationalization, right? So first of all, whenever the question of limit comes, first of all, check which kind of indeterminate form is there. Put x is equal to 0. So 1 minus 1 upon 0. So 0 by 0 form is there, right? So try to use the rationalization method. So let's see if whether the rationalization will work or not. Because that is the first method you can think of whenever you see some square root, right? Rationalization. So now multiply and divide. Now multiply and divide with under root of 1 plus tan x plus under root of 1 plus sin x divided by under root of 1 plus tan x plus under root of 1 plus sin x. Clear? So this can be written as limit x tending towards 0. What is this? A minus b into a plus b, which is a minus a square minus b square. So a square minus b square upon x cube into under root of 1 plus tan x plus under root of 1 plus sin x. Clear? So this is nothing but tan x minus sin x, right? So this is written, this can be written as, see, this can be written as limit x tending towards 0, tan x minus sin x upon x cube divided by limit x tending towards 0, under root of 1 plus tan x plus under root of 1 plus sin x. Can we write it like this or not? I have just separated. This is one expression and this is another expression. Since it is not an indeterminate form, so directly we can substitute x is equal to 0 in this, right? So this can be written as, put x is equal to 0, 1 plus 1, 2. So 1 by 2 limit x tending to 0, tan x minus sin x upon x cube. Is it still an indeterminate form? Let's check. It is 0 by 0, right? It is 0 by 0. So it is still an indeterminate form. So how we can get rid of it? One thing you can do is, everyone please pay attention now. Thus tan x can be written as sin x upon cos x minus sin x upon x cube. Yes or no? Now, this can be written as limit 1 by 2, limit x tending to 0, sin x can be taken common upon x cube, and this is written as 1 minus cos x upon cos x. Clear? Is this clear? So just convert this in the sine cos form, you will get this. So this can be written as 1 by 2 into limit x tending towards 0. Can I write it like this? Sin x upon x into 1 minus cos x upon x square into 1 upon cos x. Can I write it like this? Right? So do you remember the fundamental theorems of the limits, the product rule? So this can be written as 1 by 2 into limit x tending towards 0 sin x upon x into limit x tending towards 0 1 minus cos x upon x square into 1 upon cos x की limit तो directly we can find because this is not a indeterminate form, right? Cos x. Clear? So this can be written as 1 into, what is the limit of x tending towards 0 sin x upon x? 1. What is the limit of x tending towards 0? 1 minus cos x upon x square? 1 by 2 into, put x is equal to 0 in 1 upon cos x, you will get 1. So it means the answer is 1 by 4. So 1 by 4 is the answer. Clear everyone? JNV Balari, JNV Chitra Durga, everyone please quickly reply in the chat box. Is this clear? Is this clear or not? Quickly. We have just rationalized it, and then again it was 0 by 0 form. Then convert the tan in the sine cos, and then directly we can see that sin x upon x, we can know the limit 1 minus cos x upon x square. That also we know. Then separate it and find the individual limit and get the answer. Clear? Is this clear? Do you have any doubt? Please let me know if you have any doubt. Guys, please let me know if you have any doubt. Is there any doubt? Clear? Okay. If it is clear, students, so please, I'm giving you 2 minutes, okay? I'm giving you 2 minutes. Please solve this question, okay? You have 2 minutes, find the limit of this. Your time start now. Everyone, solve this question. You have only 2 minutes. Good afternoon, Sudarshan. Good afternoon. Please, everyone, solve the question. Everyone. It is again, what do you see? Are you seeing some square root, right? So first thinking should be go that, sir, maybe we can do that by the rationalization, right? That should be your first thinking. So try to do it. First see whether can you do it by the rationalization or not. Everyone, start doing it, start attempting. You have only 1 minute and half, 1.5 minutes left. And please let me know in the chat box when you get the answer, okay? Everyone, please let me know in the chat box when you get the answer. Anybody got the answer? Yes, JNV Ballari, JNV Chitra Durga. Did you get the answer? Sudarshan, Aniket, everyone, please let me know quickly in the chat box. You got the answer? What's the answer, guys? Okay, pay attention here now. Everyone, please pay attention now. Yeah, please. Yeah. So as you can see here, we have a square root, right? We have square root, right? So first thing should be, first of all, check whether which indeterminate form it is. Put x is equal to 0. You will get 1 minus cos 0 square root of cos 0. So 1 minus 1 upon 0. So 0 by 0 form, right? So the first thing should be you have to do is get rid of this square root. Okay. So how you can do it? Using the rationalization, simple. Cos 2x divided by x square into 1 plus cos x under root of cos 2x divided by 1 plus cos x under root of cos 2x. Clear? Is this clear? So numerator mein you will see it is becoming a minus b into a plus b, which can be written as a into b, a square minus b square. So a minus cos square x into cos 2x divided by x square into 1 plus cos x under root of cos 2x, right? Cos 2x. So as you can see, students, this is not this expression is not contributing in indeterminate form, right? So we can directly substitute x is equal to 0 for this expression. So put x is equal to 0, what you will get? 1 plus 1, right? So it means limit is 1 by 2 limit x tending towards 0, 1 minus cos square x into cos x, cos 2x divided by x square, right? X square is na? Okay. So how you can find it? Again, can I write it like this? It is cos square x, okay, into cos 2x can be written as cos 2x in terms of sine square x, 1 minus 2 sine square x upon x square. Clear? So what is this now? Limit 1 by 2 into limit x tending towards 0, 1 minus cos square x plus 2 sine square x cos square x divided by x square, right? So what is this become? Half into limit x tending towards 0. 1 minus cos square x is sine square x plus 2 sine square x cos square x divided by x square. Clear? Clear? Now, can I write it like this? 1 by 2 limit x tending towards 0. Take sine square x common in the numerator. Take sine square x common in the numerator. So it becomes sine square x into 1 plus 2 cos square x divided by x square. Right? Right? So can I write it like this? 1 by 2 into what is the limit of? This is nothing but limit x tending towards 0 sin x upon x ka whole square into limit x tending towards 0 1 plus 2 cos square x. Since 1 plus 2 cos square x is now free from the indeterminate form, right? So this can be written as 1 by 2 into what is the limit of sin x upon x? 1. So 1 square into what? Now directly substitute x is equal to 0 here. So what you will get? 1 plus 2. So you are getting 3 by 2. So it means 3 by 2 is the answer. So limit of the required question is the 3 by 2. Is this clear? Is this clear? Everyone, please tell me quickly. So see, as soon as we have done the rationalization, things become quite clear, right? Is this clear? Tell me quickly in the chat box how many of you understood this. Quickly. If you have any doubt, please let me know in the chat box now. Students, if you have any doubts now, please let me know in the chat box. Is there any doubt? Is there any doubt? Clear? Okay. If it is clear, then let's proceed further. So now let's solve this question, everyone. I am giving you again 1 minute. You have students. You have 1 minute. Solve this question and tell me the limit. Everyone, you have 1 minute. Your time start now. Solve this question and let me know the answer in the chat box quickly. What is the answer you are getting quickly? Let me know in the chat box. First of all, tell me which kind of indeterminate form it is. Check. Put x towards infinity. So you will get infinity into e raised to the power 1 upon infinity. So e raised to the power 0 minus 1. So 1 minus 1. So it is 0 into infinity form, right? So whenever you have 0 into infinity now, so you can create it infinity upon infinity or 0 by 0 form. Simple. Okay. And then you can proceed. Clear? So whenever you have 0 into infinity form, either convert it into infinity upon infinity or convert it into 0 by 0 form. Clear? So everyone solve this question. Let me know the answer quickly. Anybody got the answer? Janvi Chitra Durga, Janvi Ballari. Did you get the answer? Okay. So everybody, please pay attention now. First of all, since can I write it like this? So what I'm trying to do is I'm trying to convert this into the 0 by 0 form. Okay. So how I can do it like this? This can be written as limit x towards infinity e raised to the power 1 upon x minus 1 upon 1 upon x. Right? Now as you can see, so put x is equal to infinity, you will get 0 by 0 form. Right? Right? So now let yes, students, are you there? Okay. Yes, 1 second. Yeah. Yes, 1 second, students. Just let me reconnect it again. Okay. Yeah. So please pay attention now. So as I was saying, we can convert this into the 0 by 0 form, right? So as x tending towards infinity, y tending towards 0, right? Y tending towards 0. So can I write it like this? The above limit, can I write it like this? Limit y tending towards 0, e raised to the power y minus 1 upon y, right? This can be written as e raised to the power y minus 1 upon y. And what is the answer of this? E raised to the power elephant minus 1 upon elephant, where elephant is tending towards 0, 1. So this is your answer. Is this clear, everyone? Quickly let me know in the chat box. Is this clear? Everyone, clear? Do you have any doubt? Okay. So that's all for today, everyone. So please solve this question in your homework. Okay. Please, everybody, please solve these two questions in your homework. This is the first question. And other question is this. And this is very important question. Okay. I will start the tomorrow's class from this question. And this is the fractional parts. Okay. Fractional part. of x. Okay, so that is fractional of x minus 10. Okay, clear? So that's all for today, everyone. In the next class, we will continue with the some important result, and then we are going to look at the different. Yes, thank you, Janvi Valari. Thank you. So thank you. Okay, so that's all for today, everyone. Let's meet in the next class. Okay, bye, everyone. Please solve this question in your homework. Okay, bye, everyone. Take care. Bye, everyone.